So for the fourth problem, it's about the active bandpass filter. So how can we form a bandpass filter? We can use high pass filter and in series with a low pass filter. So this is the frequency response for the high pass. This is the frequency response for the low pass, and here this is the band pass. So using operational amplifiers of amps. So the first part is the low pass filter, is the active low pass filter, and then is connected in series with the high pass filter, the active high pass filter, and then I used an inverter. The input is connected to the low pass filter. So for this circuit here, for the cutoff frequency, I selected FC1 to be 5 kilohertz, FC2 to be 29 kilohertz. But for this is the high pass, right? So for the high pass, I'll be using FC1. So with FC1, the 5 kilohertz, I selected C1 to be 4.7 nanofarad, and I calculated R1 using the formula we used in part 3, which is omega C equals 1 divided by 2 pi RC. And I got R1 to be 3.3 kilo ohms in parallel with the 39 kilo ohms. For FC2, I selected 29 kilohertz and I selected C2 to be 2.2 nanofarad. I got R2 the 5.6 kilo ohms. And for the inverter here, I selected the input resistor to be 1.5 kilohertz and the output resistor to be 3.9 kilohertz to get a gain, a 2.6 gain. So for the active band pass filter, here's the frequency response, and in order to get the maximum voltage, I have to be somewhere here in the function generator. So for the I selected FC1 to be 5 kilohertz and FC2 29. So I'll do somewhere here at 13 kilohertz, and then I'll decrease after I divided the maximum by root 2. I'll decrease the frequency on the function generator to get FC1, and then I'll increase it again to get FC2. Now let's see the circuit. So here's the circuit. It's a bit huge. So here's the input from the function generator. So the first part is the low pass. The second part here, the second operational amplifier, is the high pass, and the third part is the inverter. And now let's apply power and signal and see the output on the oscilloscope. So on the function generator, I put this on 30 kilohertz frequency, 13 kilohertz, and amplitude 2 peak to peak, and we'll apply the signal. And then we'll apply the signal. We notice the outputs of the scale. I think I'll maximize channel 2. So peak to peak 2 is 2.25. If I divide this by root 2, at 13, divided by root 2, I get the 1.3 So I'll decrease the frequency. So the 1.56 gives us the cutoff frequency, the FC1, which is 5 kilohertz, and it's exactly as the selected FC1. And then for FC2, I increase the frequency again. It's 31.5, and there's a difference between FC2, the selected one, which is the 29, and the 31, but this is acceptable. And this is it for the fourth part.